Okay, again, because of the fact that we changed those love letters a little bit as far as the order of when you're going to present that, you will actually present those love letters on the 19th and 20th. So A-Day will present tomorrow, you guys will present on Thursday. Looking at other love letters and presentations from other teachers, a lot of people went pretty far out. Hey, make it creative, make it your own. You've had enough time to do that. However you however you decide to do it, just please make sure to read the rubric, making sure that you're good to go. Because I will have a sheet of paper that I'm basically just grading all the things that are visual and presentation-wise on that rubric, and then I'll go back and then look at your presentation a little closer to see, did they mention all of these pieces? Did they mention all of those pieces? All right. So this homework, this homework, this homework, and this homework, and finally the one that you grabbed today, this worksheet that you grabbed today, will all be due for you, I believe, on the 24th. Okay, so next Monday, I think A-Day is due this Friday. Guys, it's not that many problems. There's like 4 or 5 problems from each of these sections that I circled. So it's probably like 20 problems with that worksheet that would be due next week. Today we're going to look at this inverse. We're going to do some desmos, okay? Getting some familiarization with these radicals and these transformations of square root functions. Okay, so square root functions, transformations, the attributes as far as their domain and range, restrictions, all that kind of stuff. And then we'll also kind of correlate it to cube root functions. So where the 3 is here, otherwise x to the power of 1/3. Okay, and we're going to work with transformations and attributes of that as well. Nonetheless, these two are paper kind of notes. This is an activity that you'll do for a good 15 minutes. This Desmos, working through it, getting practice with it, and I'll record at least how to sign in on that. But we're going to first start off with this lesson quiz. This is not for a test, it's just to see where you're at. So we had really, really awesome PD last Friday, so professional development for teachers. And I really liked what we learned on Friday and the fact of sharing your work. It's called argument-driven mathematics. So I'm always saying, if you can say it simply, you know it well enough yourself. Okay, Flipgrid, you probably heard me say that I've started to use that with my calculus classes because I want them to put themselves out there. I want them to record what they know so that the world can see what they know and how well they can explain it. And it's not to put you down in any way, it's to build your math literacy so that you know how to not only write it, but you know how to speak math, okay? With that being said, what I want to do is kind of intro you into that today. So you see these big whiteboards that I have up here at the front of the room. These whiteboards, I have 6, one for each team. Basically what I want you to do is you're going to present and build that math literacy. So today it's not going to be argument-based driven where you're trying to say this is the best way to solve this out and this is why we think that. It's more so this is what we did, and I'm getting practice with not only presenting and speaking to people and letting them know what we did, but also critiquing each other. You know, well, why did you choose that? Or why did y'all have this notation? And so on and so forth. So you at least have a blueprint to go off of. You have examples of how they look like, but I really want you to be creative. I want you, like, if you find something in the way you do it, express it, show it. Don't just necessarily make it too kind of like mathematically boring, if you will. Just, you know, get different variations of colors or whatnot. Make it easy to understand with visuals, but also with your presentation. I want you to build that math literacy. All right, so what we're going to do is we're going to do 1 together, and then 2, I'm going to let you do in groups. Okay, and I'll give you a good 15 minutes to do a basic presentation. We'll erase these, and we'll do these in groups. And then what I'm going to do is I'm going to record what you did. Okay, so I didn't give them enough because I kind of just decided to do this morning. I didn't give them an example to where these are kind of like really, really, really nice professional looking. A couple of them are pretty good. But I want you to see the template and then run with the template from that. Make it better, make it more elaborate, whatever. And I will visually record it with my phone, and I will throw it on here on the calendar so that you could see actual examples later on and be like, oh, what did group 4 do? What did group root 60. You know what I'm saying? And just so that you have more experience and practice. All right. So here we go. We're looking at h of x is equal to x minus 2 squared. Guys, if I ask you to tell me what's the parent function, what is it? X squared. And the transformation, anyone that occurred is what? 2 to the right. So you had a horizontal shift 2 to the right. So this is going to go 1, 2 to the right, and this right here is my function x minus 2 quantity squared. Okay? Guys, is this function, or is it a function, yes or no? Yes, why? Yep, passes the vertical line test. Okay, so if you were to ask yourself, is the inverse a function, what should be the answer to that right now? No, it's not. It's not one. No, because why? Because the original doesn't pass the horizontal line test. Okay, so here we go. Let's go ahead and find the domain of this first one. What's the domain of the one that was given to us? Anyone? All real numbers. Yeah, you can do all real numbers, or you can do negative infinity to positive infinity. What are the y range values? Y is greater than or equal to 0. A lot of people like the inequality notation. I'm kind of an interval notation myself kind of person, so 0 to infinity you could write also. So if I graphed this as a reflection across the x-axis, okay, where would the vertex lie? 0, 2 actually, right? So if this flipped across y equals x, this 2, 0 would go to 0, 2. And you would have something that looked like a sideways parabola that would fail the vertical line test. Why? Because the original failed. It didn't pass the horizontal line test. Go with me? So if I said right now, what's the domain? What would y'all say the domain of this blue inverse graph is? Yeah, x is greater than or equal to 0. Or 0 to infinity, and the range is what? All real numbers. And notice, just like we did last class and before the 4-day weekend, we were looking at the domain of the original will equal the range of the inverse. Likewise, the range of the original will equal the domain of the inverse. Okay? Alright, so find the inverse. Let's go ahead and do the work to find that. And this is what I want you to do on your boards as well. And be very thorough with it, methodical, show it, so that people can understand what it is that you did. So h of x is x minus 2 squared. We have y. Anyone, what's my next step that I would do? Switch the x and the y. So we have x is equal to y minus 2. Now let's solve and get the new y all by itself. Okay, so when you do the inverse, your goal is to switch that x and y and then get the new y to be all by itself. So what do I do to both sides? Square root. So I have a plus or minus square root is that. And then add 2. So I have a plus or minus square root of x plus 2. This is going to be y, but I need to change it to the inverse function. I was given h of x originally, so the inverse of f of x, if you don't know that this is read that way, please put it in your notes. This right here is the inverse function. It's the inverse of h of x. Okay? Notice again, this is a square root graph that has a positive piece to it. It also has a negative piece to it. And it looks like it was shifted vertically up 2 units. Questions so far? And the way that I'm explaining this, when you guys present, that's the way I want you to explain it, okay? You'll work in groups for 15 minutes. After that, I will choose 2 people who are going to present at your table. The other two are going to go to the other ones and ask questions and kind of critique and learn and see what other people did, and then we'll rotate. Okay? So please be ready to present what you guys did as a group. Chances are I'll pick you if you're the quiet ones. Alright, so find the inverse we already did. Use compositions to verify that the inverse you found is correct. So looking at this right now, let's go ahead and jump to F. I have to restrict the domain of the original, possibly, which in this case I do, to make the inverse a function. What's the domain restriction that I had to do on the purple original graph? Yes, x is greater than or equal to 2. I'm looking at only the right half from 2 to infinity. So on the original, which is this purple one right here, I would domain restrict this to x is greater than or equal to 2, otherwise 2 to infinity. That's the domain restriction that just happened. Okay? And when I do that, it will range restrict my inverse. And it'll range restrict it to 2 to infinity to match up this piece here. So from that, we are seeing and learning that it wouldn't be the entire graph because it would fail that vertical line test. It would only be that top half that would get graphed. Okay? So the domain restriction was 2 to infinity, which calls a range restriction on the inverse of 2 to infinity. And now we can use compositions to verify if in fact they are inverses of one another. Alright, so here we go. We're going to take, the first one was h of x, and we're going to do the inverse function to lie inside of that one. So I'll do the inverse in blue. So we're doing that. And we're going to see if this is equal to the inverse composition with h of x, the original, being inside. Okay, so on the left side, let's build the original. The original one looked like this. Something minus 2 quantity squared. The inverse that we found was just the positive version, and it was the square root of something plus 2. Okay, so now I'm going to go ahead and plug in on the left side. I'm going to plug in what was the inverse that we ended up getting when we did the algebra of solving for the inverse. And what would I put right here in that slot? What did we find to be our inverse? Square root of x plus 2. This that we found to be the inverse is what's going to get plugged in as the input in this verifying proof. Okay? So, let's see what we got. If I were to go ahead and simplify this stuff in parentheses, what would that equal that I highlighted? Or square root of x, right? And then when you square it, what would it finalize as? X. So there'd be an x right here on the left. And this is the work that a lot of people struggled with, the other units that we did inverses with verifying the compositions. Please make sure that you're good to go this time around. Alright, so and then in the inverse function, I would plug in my original given f of x, which would be x minus 2 quantity squared. Yes?
Will we still carry over the plus or minus, or is that...
We don't carry over the plus or minus, so in all actuality, the answer to finding the inverse would only restrict it to this one. I just never want you to forget that there's two sets of answers when you square root, and now the new thing to add on to it, which a lot of people hate because you really have to understand what's going on, is the domain restriction on the original that would yield the range restriction on the inverse. Okay? If necessary. You're going to see here in just a bit, you don't have to do this if the original passes the horizontal line test. But be careful of how much you actually draw, because you're only drawing basically relating to what that first given function was. Okay? Guys, what would this simplify to?
X.
X or x minus 2 first, right?
Oh.
So that square root and this squared, they would cancel each other out so that you would only have the x minus 2 left over. And then afterward it would simplify to what? X afterwards. And sure enough, these are inverses of one another. Math literacy, being very, very intentional of what you're saying, how you're restricting stuff, that's what I'm looking for as far as what you're going to do here in groups in just a bit. Are there any questions so that you already know those answers before you carry it to the group stuff that you're about to do for 15 minutes? Okay, so what I want you to do is for 15 minutes with your groups, I want you to work on number 2. Kind of the same way that we did it. Make sure everyone is contributing to these whiteboards. You can grab any one of these whiteboards that you want, erase it off, transfer all the work to the whiteboard. Make sure that you agree with everything that you do, but be ready because I will randomly select those who will actually present to people that are rotating around the room, okay? Alright, so let's go ahead and do that. 15 minutes.